All right, ladies and gentlemen, welcome to the second half of 4.5. This particular half is dealing with graphing secant and cosecant, the reciprocals of cosine and sine. So everything we know about sine and cosine, we're going to use to graph these two functions. So let's go ahead and look at each individually. We're going to start off with cosecant. You'll notice here the period for cosecant is 2 pi, just as is with sine. However, in this case, the domain is anything except for the multiples of pi. The range is quite interesting. It's kind of in comparison to sine. Sine has a range of -1 to 1. And since cosecant's the reciprocal of that, that means the range for cosecant is going to be everything else. So we don't have any values of y between -1 and 1. And the symmetry for cosecant is odd, just as with the symmetry for sine is also odd. And my note down here at the bottom is, if you can graph sine, you can graph cosecant. Can't seem to say that word today. And what we're actually going to do is graph the sine function that corresponds to the cosecant function we're trying to graph. So let's look at the parent function graph first. Oops, wrong way. Here we go. And what I want to do is I want to graph the sine function. So if you recall, I'm actually going to move the 1 down to here. So let's scratch that. Let's move the -1 down to here. I'm going to scratch that. If you recall, the sine function looks like this. It starts at 0, 0. It goes up, middle, down, and middle. And what we're going to do is we're just going to kind of dash this in because it's not going to be actually part of my graph. What this is a guide for my graph. And you don't necessarily have to dash this in when you do your functions, but what I'd like to do is to show the comparison between sine and cosecant. Now, let's change the color for our pen here. I can get it to work for me here. Let's go to blue. Now, if you think about this value right here, this tells me that the sine of 0 is equal to 0, which means the cosecant of 0 is the reciprocal of 0, which is undefined. So everywhere that sine crosses the x-axis is an asymptote for cosecant because it creates an undefined value. And so we have a whole bunch of asymptotes. And in one period of cosecant, you get 3 asymptotes, one in the middle and one at the end. Then, if you think about the sine of pi halves is 1, therefore the cosecant of pi halves is also 1 because it's the reciprocal. Now, these values here are smaller than 1, however, their reciprocals are bigger than 1. And think about any number, 3 over 4, which is smaller than 1, but its reciprocal is 4/3, makes it bigger than 1. And the smaller that fraction gets, the bigger its reciprocal gets. And likewise in the other direction. And so we get this piece here. This blue piece is the first half of the cosecant function. And it goes in the same fashion on the other side, on the other half of my period. For the sine of 3 pi halves is -1, therefore its reciprocal is -1, and the pattern continues thusly. This is one full period of cosecant. Notice it has an upwards u and a downwards u. They're almost like a parabola, but not really. Just like tangent and cotangent were like cubics, but not really. So you'll notice even with the parent function, I started with graphing the sine function. And so we're going to do that in every single method. So everything we learned from sine and cosine, we're going to use that for cosecant and secant. And let's start with, this is my only cosecant example here. We're going to think about it like a 2 sine of 2x plus 2. So we're going to find our period. It's exactly like finding sines because it is sine. So we're going to go the 2 pi over 2, the b value here, right, is pi. I have a center line at y equals 2. And I have an amplitude of 2. No phase shift in this one. Let's kind of keep it simple here. But because I'm going up 2 with an amplitude of 2, I need to go all the way up to 4 and down to 0. So I'm going to kind of do this here. I'm going to go 2, 4 with my little middles in there. I'm going to put in my center line. And then I'm going to think about what the sine function is going to do. The period is pi, so out here has to be pi. In the middle has to be pi halves. And then I need my pi fourths. Just as every time we've done sine. Sine, since there's no phase shift, is going to start at the 0. It's not negative, so I'm going to go up first. I'm going to go to the middle. I'm going to go down. And I'm going to go back to the center line. Now, you can draw in those dashes or the dashed sine curve if you really want to, but I just used these values to figure out how to draw cosecant. And I'm going to change my pen color again back to red because everywhere that sine crosses the center line, not necessarily the 0, it's whenever that makes a center line value, creates my asymptotes. And a maximum for sine, which is this value, becomes a minimum for cosecant. And a minimum value for sine becomes a maximum value for cosecant. Make sure you don't cross your asymptotes there. That's illegal. And there we have the cosecant function for this example, or the cosecant graph for this example. All right, that's our only cosecant example. We're going to go straight into the secant because we know everything we need to know for sine and cosine again. So in this case, for secant, the period is still 2 pi because the period for cosine is 2 pi. The domain in this case, the cosine crosses the x-axis at the pi halves, and so it's pi halves plus any multiple of n pi, and that's where our asymptotes occur. The range is the same because the range for sine and cosine are the same. And in this case, it's even symmetry because cosine has an even symmetry. And again, if you can graph cosine, you can graph secant. So let's look at the parent function graph. We're going to draw in the cosine. Again, I'm going to move these down. I used a preset graph here. Move those a little bit closer here. Now for cosine, remember the red is going to be the cosine of x. So cosine normally starts up. It's going to go to the middle, bottom, middle, and top. And it's going to go thusly. And I didn't really mean to draw that in as a solid line. Think of it as a dashed line because it's not really there when we draw for drawing secant. Now, everywhere that cosine is 0 or crosses the center line, it creates a reciprocal of undefined, which makes a vertical asymptote at those zeros. Now, there are more. Obviously, we can keep going in either direction. And my straight lines are getting less straight here. But what we want to know is, in the same fashion as cosecant, the maximum for cosine, its reciprocal is 1, so it stays 1. And then the numbers that get smaller for cosine get bigger for secant. And in the same fashion, it looks exactly, or almost exactly, like secant. And that should be kind of expected. Since cosine and sine look almost identical, secant and cosecant should also look pretty identical. If you wanted to continue this pattern, it would go like this. It would go like this. And it would continue forever. Now, this is 2 full periods for secant. I'm going to leave us off with one example here of secant in the same fashion of the cosecant function. We're going to look at 2 cosine of 2x minus 2. So my period, just as we did with cosine, my period is 2 pi over 2, which is pi. My amplitude is 2, and my center line is y equals -2. So again, because I have to go down to -2, my amplitude is 2, I'm going to go down to 4. Wow, my straight lines kind of suck on this. I'm going to put in my center line. Now my period is pi, so no phase shift, so no left or right. So I'm going to go from 0, I'm going to go out to pi. I'm going to cut it in half again. Gets my pi fourths, my pi halves, and my 3 pi fourths. And I'm going to draw in the cosine for this function. The cosine is going to start up. It's going to go to my center line. It's going to go to my minimum, center line, maximum. Now, in the same fashion as cosecant, I am going to draw in my asymptotes. My asymptotes occur every time that cosine crosses the center line. So at the pi fourths and the 3 pi fourths. And then I'm going to use that maximum as a minimum. I'm going to use that minimum of cosine for a maximum of secant. And I'm going to use that maximum as a minimum. This is one full period of secant. You could continue this in either direction as far as your heart desires. I'm going to leave you with that. Hopefully this one was a little shorter here, and I hope that you learned, again, a lot, and I will see you guys tomorrow.